Now, section 5.5 is a long section that we're going to be breaking up into 4 days because it's a very dense section, and we're going to go through like kind of each part of it separately. And today what we're going to be working on are what are called double angle formulas. So double angle formulas, we experienced those when we were solving. We had like, all right, cosine of 2 theta equals pi over 2, and we had to go around the circle twice because of that 2. So we're going to revisit that. Now on our formula sheet, I want to point out for the double angle formulas right here that for cosine of 2x, there are 3 different formulas we could use for it. And you would say, well, how do I know which one to use? It's situational. Like you could use any of them at any point, but one might be way more efficient than the other. Like if we want to just have sine in our answer, well, we want to use 34. If we wanted just cosines in our answer, we want to use 32. We might want to use 30 if we have like another trig function that we can cancel out with either the cosine squared x or sine squared x. So it's going to be situational on which one to use. But for sine and tangent, we just have the 1. So let's look at this here. Now we have a right triangle, and it's a Pythagorean triple. So if you know it, you know that's 13, but then you could do 5 squared plus 12 squared if you were unsure of what this value would be. So the cosine of this angle, cosine is, these are angle adjacent over hypotenuse, so 5 over 13. Now, it's important to note that the cosine of 2 theta is not 2 times the cosine of just plain theta. Like we can't take this 2 and move it out front. It would be super convenient. So now cosine of 2 theta, like I said, we could use any of the formulas that we want for that, any of the 3 formulas. I'm going to use number 30, the first one, just because we have all 3 sides already. Like if we didn't know the opposite side, then we would, using the formula 30 or 34 with sine squared in it, might not be a good idea. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Well, cosine we already know is 5 over 13 squared minus sine is our opposite over hypotenuse, so 12 over 13 squared. So then we get 25 over 169 minus 144 over 169, which equals negative 119 over 169. So cosine of 2 theta wasn't anywhere close to what the cosine of theta was, 1 theta. So example 2, use a graphing calculator to approximate the equation solution between 0 and 2 pi, then find the exact solution algebraically. Well, I think we did enough practice with the graphing calculator, so we're going to solve these algebraically. Now, we can't just, again, rewrite this as a single term right now. We can't combine that because this is 2x and that's x. So we must have the same angle. All right, so what we can do is we can change this. You say, okay, looking at our double angle formulas, it wouldn't make sense to bring in a sine here. Using formula 30 or 34, it wouldn't make sense to bring in sine because now we have 2 trig functions to deal with. So I'm going to use number 32, where we can change it to cosine to the first power, cosine squared of 1x. So according to the sheet, this is equal to 2 cosine squared x minus 1. And then we have plus cosine x equals 0. And it's important to note that that minus 1 is not part of the angle. So now I'm going to add 1 to, nope. So let's rearrange this. 2 cosine squared x plus cosine x minus 1 equals 0. So since this is equal to 0, we can rewrite this in quadratic form. So we're going to factor it. So just like if this was 2x squared plus x minus 1, and you'd factor that, I'm going to factor it, but instead of x, it's going to be cosine. So this factors to 2 cosine x minus 1 and cosine x plus 1 equals 0. And I did that kind of by guess and check, but more the process of elimination, because we have to get minus 1 at the end and a positive positive cosine right here. So the only way to do that would be with these two factors. So now we're going to set each factor equal to 0. So 2 cosine x minus 1 equals 0. And cosine x plus 1 equals 0. And we'll solve these separately. So we have cosine x equals 1, 2 cosine x equals 1. Cosine x equals 1/2. So x is equal to pi over 3 and 5 pi over 3. And then we'll solve the other one here. Cosine x equals -1. Well, that occurs at just pi. So those would be our three solutions. Then letter B, we have sine 2x plus cosine 2x quantity squared equals 1. So we're going to multiply this out. Remember, we can't just distribute the square. So we're going to use the shortcut. So this will be sine squared 2x plus 2 sine 2x times cosine 2x plus cosine squared 2x equals 1. This FOILs out into that. Well, we know that sine squared of any angle plus cosine squared, if those angles are the same, that equals 1. So it's 1 plus 2 sine 2x cosine 2x equals 1. Subtract 1 from both sides. So we have 2 sine 2x times cosine 2x equals 0. Well, now we can divide both sides by 2. So sine 2x times cosine 2x equals 0. And since we have two things being multiplied, we can set this equal to 0. And then we can set this equal to 0. Now, could I have used a double angle formula to convert this? Yes, but it would have made it a little bit more complicated, because then I would have two different angles, and that's okay, but it would just create more work. This will be a little bit easier because there's not as many answers. So 2x equals 0. So when is when is sine equal to 0? That is at 0 and pi, but remember that 2 means we need to go around twice. So 2 pi and then 3 pi. And then when is cosine equal to 0? Well, cosine is equal to 0 at pi over 2 and 3 pi over 2. And again, because it's 2x equals, we have to go around the circle again, so add 2 pi. So 5 pi over 2 and 7 pi over 2. And for each of these, we have to multiply both sides by 1/2. So x equals 0, pi over 2, pi, 3 pi over 2. That takes care of the sine part, the left one. Then for the left one, then the one on the right, we're going to have pi over 4, 3 pi over 4, 5 pi over 4, and 9 pi over 4. So those would be our solutions. And then letter C, okay, we have sine 2x times sine equals cosine x. Again, we have to have the same angle, so we're going to change this into something using our formula. Formula 31 says sine of 2x equals 2 times sine x times cosine x. Whoops, I forgot the extra. Okay. So we have that times sine x equals cosine x. So this is equal to that, and that extra sign was already there. Now, I'm going to multiply, though, this sign and this sign, so I have 2 sine squared x times cosine x equals cosine x. Now remember, we can't divide both sides by cosine x because we could be dividing by 0. So instead, we're going to subtract that from both sides. So 2 times sine squared x times cosine x minus cosine x equals 0. Now we have two terms here, this term and this term, that we can factor a cosine out of. So cosine x times 2 sine squared x minus 1 equals 0. So now I have two things being multiplied that equals 0. We can break this up into cosine x equals 0 and 2 sine squared x minus 1 equals 0. Well, the left part is easy. Cosine is equal to 0 at pi over 2 and 3 pi over 2. So x equals pi over 2 and 3 pi over 2. The right side is going to require a bit more work. Add 1 to both sides. Divide by 2. Sine squared x equals 1/2. Square root both sides. So sine x equals plus or minus the square root of 1 over the square root of 2. Well, we can't have that, so we multiply the top and bottom by the square root of 2. So sine x equals plus or minus the square root of 2 over 2. So when is sine equal to the positive or negative square root of 2? Well, that's at our pi over 4 intervals. So pi over 4, 3 pi over 4, 7 pi over 4, I forgot 5 pi over 4. So again, knowing that unit circle is absolutely important for these solving problems. And we were able to use that double angle formula to convert this to just sine and cosine of a single angle of x. All right, now the next page, it says use the double angle formula to rewrite the expression. It says 5 minus 10 sine 2x. So if we look at this formula, the formula sheet, the only formula that has sine squared in it, or only two formulas have sine squared in it, is cosine squared x minus sine squared x. And then 1 minus sine squared x. Sorry, 1 minus 2 sine squared x. Those are the only two formulas that have a sine squared in them. So I know I'm going to use one of those. Well, if we can look at this, we have 1 and 2, 5 and 10. 5 times 2 is 10. So if we factor out a 5, that's 1 minus 2 sine squared x. So now these match perfectly. And we say, well, on the formula sheet, that is equal to the cosine of 2x. So then 5 times the cosine of 2x. And that would be our final answer. Okay, we're just going backwards with the formula for that problem. All right, example 4. It says, given that cosecant of x equals 3, and pi over 2 is less than x, which is less than pi, so we got to think about what quadrant that's in. Right here, that means quadrant 2, because the angle is bigger than x, the angle is bigger than pi over 2, but smaller than pi. So that's quadrant number 2. And if we know that cosecant is x, that means sine of x is 1 over 3. So if we were to draw that triangle, we have 1 as the opposite side and 3 as our hypotenuse. We need to find that side. Now we say, well, why do we need to do that? Well, because we're asked to find the sine of 2x, cosine 2x, and tangent of 2x. So it's a good idea to have all of our side lengths. So we have 1 squared plus x squared equals 3 squared. So x squared equals 8. Square root both sides. We get x equals the square root of 2 times 2. Or let's write this as 2 times the square root of 2. So now we have all three of our sides, and if I'm looking at my formulas here, I need the sine and cosine and tangent to figure these out. So I'm just going to identify those up top here. So the sine of x is equal to 1/3. The cosine of x is going to be negative 2 times the square root of 2 over 3. Negative because we are in quadrant 2. And the tangent of x is equal to the opposite over adjacent, so 1 over 2 times the square root of 2. And I'm going to leave it like that for now. I may change that later on, but for now I'm going to leave it like that, because when I look at my formulas, we are squaring tangent for tangent of 2x, so let's just leave that for now. So now the sine of 2x. Well, for the sine of 2x, you only have one option. That's 2 times the sine of x times the cosine of x. So this is equal to 2 times 1/3 times negative 2 square root of 2 over 3. So we multiply that up. Remember, this is really 2 over 1. So that gives us negative 4 times the square root of 2 over 9. So that's all we do for that one. Now cosine of 2x, again, we have options. Oops, not cosine squared 2x. Cosine of 2x. We could use either one of the three formulas we have. Now, I'm going to use the cosine squared minus sine squared formula because we already identified what those are. If we use any of the other ones, we're going to have to then get common denominators. Let's see, we already used that one though, so let's use a different one. So I'm going to use the one with sine in it. So 1 minus 2 sine squared theta. And now that I'm thinking about this, it's probably a good idea to use that one because we were given what sine is from cosecant. So if we made an error calculating this adjacent side and then use that over here, that's going to make this wrong. So 1 minus 2 times 1/3 squared. So that's going to be 1 minus 2 times 1/9. That's going to give us 1 minus 2 over 9. Well, we can't have that. We need common denominators. So this will be 7 over 9. All right, now the last one, tangent. And of course, tangent has to be difficult. So the tangent of 2x is equal to 2 times the tangent of x over 1 minus tangent squared x. So now let's replace those with what tangent is. So we have 2 times, our tangent was 1 over 2 times the square root of 2. Sorry, negative 1 over 2 times the square root of 2 over 1 minus tangent squared. So when I multiply the 2 in, remember it just goes to the top, so they would cancel with that 2. So it's going to be negative 1 over the square root of 2 over 1 minus, well, remember this 2 is not multiplying 2, it's squaring 2. So it's going to be 1 over, and when we square the denominator, we square the negative 2, which will give us positive 4, times the square root of 2 squared, which is 2. So we'll get negative 1 over the square root of 2 over 1 minus 1/8. We need to get common denominators, so negative 1 over the square root of 2 over 8 minus 1 over 8 equals negative 1 over the square root of 2 over 7 over 8. So now we have to get rid of that 7 over 8 in the denominator. So we can multiply by the reciprocal instead. That's going to give us negative 8 over 7 times the square root of 2. We're still not done because we can't have that square root in the denominator. So then we get negative 8 times the square root of 2 over 7 times 2. We're almost done. So then we get negative 8 times the square root of 2 over 14, which can be reduced to negative 4 times the square root of 2 over 7. So yeah, tangent, as always, is kind of a pain. And it's because tangent can be written as sine over cosine, so there's a lot more to it. So your algebra skills are really going to come into play here because we're just using the formulas, substituting in the values, and then using algebra to simplify. So we have to make sure we are careful with our algebra skills. So thanks for watching. Make sure to like and subscribe.